Hello friends, welcome back to our channel Abi ChemistryTutorial. So in this video we are going to discuss about Acyloin condensation. So we are discussing the organic naming reactions in this series and this is the third reaction we are going to study. So I have already posted Stope condensation and Darson's reaction. So if you have not watched that videos, the link is given in the description box. The playlists are available in English and also in Tamil. So you can use it as per your convenience. So before going into the video, I have a very kind request for all of you. So you are getting benefited from my videos. So kindly subscribe to my channel because I am doing these videos with a lot of efforts. And your subscriptions will boost me up to do more and more videos and which will be very useful for you also. So kindly take a second to subscribe to our channel as many people are watching without subscribing. So now let's get started. Acyloin condensation. So you might have already studied this in 12th standard. So here we are going to study the mechanism in detail. So what is Acyloin condensation? So it is a reductive coupling. So it is a coupling reaction of two esters. So coupling in a sense, two similar molecules are joined together by a reaction. So this is called coupling and here we are taking two esters, that is carboxylic esters means it is ester. So two esters are coupled to form a ketone, that is an alpha hydroxy ketone in the presence of metallic sodium. The point should be noted, metallic sodium. Okay. So the product, the ketone, the alpha hydroxy ketone is known as Acyloin and that is the reason for the name Acyloin condensation. So here is an example for you. In general, let us represent the alkyl group as R. So RCOOMe. So this is an ester as you know. So two molecules of this ester is coupled in the presence of metallic sodium using ether or benzene or xylene or toluene as the solvent to give the product alpha hydroxy ketone. So here you can see this is the functional group and this is the alpha position where you have the hydroxy group. So that is the reason alpha hydroxy ketone. So in the case of R, if it is a very long alkyl chain, then we should use highly boiling solvents. Okay, and the main condition is that all the solvents should be protic solvents, that is the solvent should release H plus. Okay, so the solvent should release H plus. Such type of solvents only should be used in Acyloin condensation. The Acyloin reaction will be more successful when this R group is aliphatic and inert. So if it is aromatic, the reaction will be not supported as in the case of aliphatic. A very important thing in Acyloin condensation is depending on the size and the steric properties. So if it is a linear molecule also, if you have the carboxylic ester group at the two ends, then you can see this will undergo an intramolecular condensation to form a ring-like structure. So cyclization occurs. So Acyloin condensation prefers intramolecular condensation rather than the intermolecular condensation. So this is a very important point to be noted. So next we are going to learn the mechanism of Acyloin condensation. So the first step is the sodium metal gets attacked on the double bond of this CO group. Yes, so sodium metal, it has 11 electrons, so 1 electron extra, you know that. So this loses this electron to form Na plus usually. So now we are taking metallic sodium. So we have an electron here and this sodium will donate this electron to carbon. So we have this type of arrow like this, not arrow mark. You should represent, if there is one electron transfer, you should represent with this symbol. Okay. So if there is a transfer of two electrons, then you can refer by this arrow mark. So here you can see this electron is shifted to this carbon and this bond is completely shifted over this oxygen so that this oxygen will gain a negative charge. As you can see here, it will gain a negative charge. And since sodium loses one electron, it becomes Na plus. So Na plus and O minus combines to form a bond ONA. And here you can see the electron donated by this sodium remains at the carbon itself. So this takes places in the case of the two esters. And now we are going to couple these two esters. So this is the step 2, free radical coupling between the two molecules. So here you can see we have got two derivatives of ester, and here you have one electron and here you have one electron. So this carbon donates an electron here and this carbon donates an electron. So these two electrons combine to form or couple to form a bond, and other groups remain the same. So OCH3 is represented as OMe and ONA and R same. So here also ONA, OMe and R. The bond is formed between this carbon and this carbon. And the next step is the alkoxy elimination. So when this bond is removed, here you get a positive charge, and to fill this positive charge, this sodium goes out as Na plus, and this bond is completely shifted towards here and it will form a double bond O, as you can see here. The same case occurs in this part also. So OMe is removed and this bond is shifted towards this oxygen and carbon, and we will get a keto group here, and finally this is a diketone since it has two keto groups. So the step 3 is the attack of sodium metal again on the diketone. Yes. So here you can see this sodium metal with one excess electron or one valence electron will give this electron to this oxygen. Okay, so this will give this electron to this oxygen, and in this bond two electrons will be there, no? So one electron will be shifted over this oxygen. So this electron and this electron combines to form a bond, that is ONA, and one electron is remained at this carbon's position. And this carbon will also have one electron, which is produced in the similar way. So sodium will give this valence electron to oxygen, and from this bond one electron will be shifted to oxygen, and this will create a bond ONA, and one electron will be remained over this carbon. So now coupling takes place. This carbon will give one electron here and this carbon will give one electron here, and a bond is formed, that is coupling is formed. Free radical coupling takes place to form this compound. So this is called sodium hexodiolate. So this may be, so this is the derivative of an alcohol, right? So this is diolate, diol. So two alcoholic groups are converted into and its derivative. So it is called sodium hexodiolate. So the final step is neutralization with water. So what will happen when you add water to this derivative of an alcohol? So as you know, NaOH and OH. NaOH and OH. So NaOH will be removed, 2 NaOH is removed, and you will get OH, OH over these two positions. And this will undergo keto-enol tautomerism. So what is keto-enol tautomerism? A keto group, a double bond O group will be converted to OH group, that is enol, alcohol group, and one alcohol group will be converted, and this alcohol group can be equally converted to this keto group. So this will remain in a equilibrium. So this is called keto-enol tautomerism, and here you can see this H goes here and this bond shifts here to form a ketone. And this is the final product Acyloin. This is the functional group and this is the alpha position. So alpha hydroxy ketone, which is Acyloin. So this is all about Acyloin condensation. So I hope this video is useful for you. So please give a like to this video and share to your friends, and don't forget to subscribe to our channel. So see you all in the next video. Until then, thank you. Bye.